One of the areas that you just touched on, sea level rise, is one of the least understood, as I understand it, and certainly one of the areas that's moved most substantially since the last IPCC report, which I think said 18 to 59 centimetres sea level rise, and that did not factor in melting of ice sheets. I think that sea level rise is probably one of the hardest projections that it's for people to get their head around, just because it seems such an extraordinary change, and we see such minute change over time in sea levels. What does the latest science tell us we can expect? How much have things moved since 2005?
Sure. So I guess maybe I should sort of correct you a little bit in the sense that you commented that sea level rise was minute. Well, depends what you mean by minute, because in fact we have already seen over the last 150 years substantial and significant sea level rise of about 30 centimetres over the last, certainly more than 20 centimetres, depending on exactly which time period you look at, over the last 150 years. That is already substantial and having adverse impacts on many coastlines.
Sure.
The rate of rise is now of the order of 3 centimetres per decade, or expected, if it was to continue in the future, at least 30 centimetres over the next 100 years. You're absolutely right, the IPCC projections were 18 to 59 centimetres over the next 100 years, but even if the current rate for the last 10 years was to continue, we would see, essentially that mid-range occurring. So, again, the IPCC assessment, because it is extremely difficult to model and estimate the contributions from melting of the Greenland ice sheet and the West Antarctic ice sheet, and to come up with quantitative estimates and uncertainties quantified for the sea level rise from those meltings of Greenland and the West Antarctic ice sheets, the IPCC came up with an estimate based primarily on sea level rise due to thermal expansion of the water. When water warms up, it expands, melting of glaciers, and some small contribution estimated from continuing rates of increase due to melting of Greenland and West Antarctic ice sheet. But that estimate was quite small, based on essentially existing estimates, not an acceleration in the melting in Greenland and Antarctica. Immediately that the IPCC assessment came out, a number of scientists felt that the IPCC had underreported the likely contribution. There is a phrase in the IPCC assessments that says that an additional 20 centimetres during the 21st century is possible in sea level rise due to contribution from Greenland and Antarctica. But that is highly uncertain. Other estimates, based on recent scientific papers using a range of different approaches, have suggested that sea level rise up to 1.3 metres or 130 centimetres is possible by the end of the 21st century, which is essentially double the sea level rise projected in the IPCC assessment of 59 centimetres. Those faster rates of sea level rise are supported by recent observations of faster melting of the ice sheets in Greenland, and also faster rates of warming in Antarctica, particularly around the coastline of Antarctica and the Antarctic Peninsula, and faster rates of melting of sea ice, particularly in the Antarctic Peninsula and the West Antarctic ice sheet. All of those indicate that warming is occurring and accelerated melting is occurring in those regions. However, modelling of the rate of loss of ice in Greenland and Antarctica is limited by the difficulties in actually representing those rapid ice loss processes. There are very large uncertainties. It's very unlikely that the 7 metres of sea level rise that are locked up in ice in Greenland will be manifested completely in the 21st century. It's very, very unlikely that we could see 7 metres of sea level rise in the next 100 years.
Even worst case scenario.
Even worst case scenario, Greenland is a very, very, very big ice block. And even if it slumped, it would be difficult to force that amount of ice through the mountain ranges that limit the glacier flow into narrow valleys around in Greenland. It can't. The best information from glaciologists is that it can't slide, slump, flow, whatever word you want to use, into the ocean quickly enough to cause that. However, there are certainly scientists who are saying that metres of sea level rise are possible in the next 200 years, and that the 7 metres could be manifested in the order of 200 to 500 year timescales. Unfortunately, there are a lot of uncertainties in that.
If we continue at the current rate in the next 50 years, what will the impact be? Which parts of the world will we see disappear? What will the impact be here in Australia?
Well, okay, in terms of sea level rise in the next 50 years, I think the upper range of the sea level rise estimates are probably only an additional 30 to 50 centimetres. Yeah. Because the sea level rise accelerates as the warming is projected to accelerate. Although it's important to understand that the sea level rise response to emission reductions is incredibly slow. And a lot of the sea level rise is already locked into the system. Irrespective of whether we dramatically reduce emissions or they continue to grow, sea level will continue to rise at much the same rate. 30 to 50 centimetres is certainly possible in the next 50 years. 30 to 50 centimetres will have major adverse impacts on many low-lying areas, including in Bangladesh, including in the Mekong Delta in Southeast Asia, including in the Nile Delta in Africa, including in the Amazon Delta in South America. In terms of Australia, Australia has a lot of coastal developments that are going to be adversely impacted. And so some of the areas that have been studied include the Gold Coast, but there are also major adverse impacts on many parts of the coastal infrastructure that will be substantially adversely impacted over the next 30 and 50 years. There are already limits being put on coastal developments or requirements that coastal developments in Australia take into account sea level rise estimates at the upper limit of the IPCC. So I know that planning permission now requires consideration in many areas for the likely adverse impacts from sea level rise. But of course there are many other impacts in Australia from climate change projected over the next 30 to 50 years, including adverse impacts in terms of ongoing rainfall declines in southwest, Western Australia and southern Australia, increases in evaporation associated with hotter temperatures and also reductions in rainfall in the southern Murray-Darling Basin, increases in hot extremes and increases in heat waves and bushfires like we've seen in southern Australia in the last several months. Those projections, those impacts of climate change have been, I guess, forewarned or foreshadowed by climate change scientists for more than a decade, and we have certainly been experiencing them over the last, over this summer period and also over the summers over the last several years in southern Australia. We also expect adverse impacts in terms of increases in heavy precipitation. And unfortunately, Queensland and Northern Australia has also been seeing weather variations, flooding and very heavy precipitation that is also consistent with the expectations due to climate change. We can't specifically attribute the very heavy rainfall that we've seen in Queensland or Northern Australia to climate change, but we certainly expect increases in heavy precipitation associated with climate change. So they're consistent with what we expect from climate change, but they're not outside the range of natural variability yet. What climate change does in terms of some of these extremes is increase the likelihood of these extremes occurring or reduce the return period, increase the frequency of their occurrence. So we expect, due to climate change, increases in the frequency of occurrence of heat waves, increases in the frequency of occurrence of bushfires, and increases in the frequency of occurrence of, say, flooding and extreme heavy precipitation.
In the case of the bushfires, the tragic bushfires we've had in Victoria this summer and that are threatening Melbourne even today as we speak, what does the science tell us about the likely frequency of extreme conditions that could lead to catastrophic bushfires?
Sure. The science says that we expect that frequency of occurrence to double in many areas over the next 20 years. And we've already seen a marked increase in frequency even over the last 50 years. Analysis by CSIRO and the Bureau of Meteorology has already shown marked increases in the average fire danger, which takes into account things like higher maximum temperatures, lower humidity, and increased drying of the fuels. When we look at those, we see observed increases, and part of that is directly attributable to climate change. The increases in maximum temperatures in Australia are directly attributable to climate change, on average. And we expect increases in frequency of extreme fire danger and catastrophic fire danger situations over the next 20 and 50 years. Marked reductions in the return periods, marked increases in the frequency. So we expect them to occur probably twice as frequently as in many areas of Australia.
What does all this that we've discussed tell us about the sort of cuts we need now?
Well, obviously it says that with unmitigated climate change, there are going to be many, many adverse impacts. So the IPCC looked at what sorts of emission reductions would be needed to essentially minimise dangerous climate change, to try to minimise the warming of the climate system, to try to keep it down to only 2 degrees or 2.4 degrees above pre-industrial. And what it found was that the emission reductions that would be needed, we needed to have a peak in global emissions, essentially now, globally, and definitely a peak in global emissions by 2015. Emissions would need to reduce by between 50 and 85% globally for all countries. So 50 to 85% emissions for all countries. Now, Australia's emissions are approximately 5 times the global average. So if we think about what that means for Australian emissions, because they're 5 times as much, and even at the very best situation, global emissions have to reduce by a half, Australia's proportionate contribution, if you like, fair contribution, would to have at least a 90% emission reduction by 2050 in about 40 years' time. And in this other case, 85% emission reductions needed, then the proportionate emission reductions for Australia would be a 97% emission reduction for Australia. Australia would need to decarbonise its economy, rapidly introduce renewable energies or other energy sources that don't release carbon into the atmosphere. Because a 90 to 97% emission reduction for carbon dioxide and other greenhouse gases in the atmosphere essentially means a effectively zero carbon economy.
Obviously, we're some distance from that at the moment, and those targets are greater than what's on the table. Without getting into the politics, what do you expect the world to look like? What do you expect Melbourne, life in Melbourne, to look like by the time your grandchild is an adult?
Hopefully I'll still be alive then, and so we're talking about 20 to 30 years' time. 20 to 30 years' time, irrespective of what happens to emissions, the changes in the climate system will be pretty similar.
Yeah.
We will have substantial warming. As I just said, we're likely to have twice as often occurrences of extreme bushfire conditions as were experienced in the late 20th century. We're likely to have nearly 50% more days above 35 degrees Celsius, more heat waves, more loss of life from those extreme heat waves. We're likely to have reduced rainfall, although not reduced from present, but perhaps ongoing reduced low rainfall. We're likely to have changes in the agricultural system. So I'm talking mainly about the climate impacts. If we are working towards reducing our emissions, then society will need to be very different as well. We will need to have most of our energy being generated from renewable sources. We will need to have much greater use of public transport. We will need to have many, many more small cars or electric cars. We will need to have a transformation in our society so that it is on the path to this zero carbon economy. We will need to have a sustainable economy and a sustainable lifestyle that takes into account the cost of waste and the cost of waste disposal. Instead of dumping carbon dioxide into the atmosphere as we've been doing for the last 150 years, we will need to make sure it's disposed of in a sustainable way, which means it's captured and stored, or it's not used in terms of our energy systems.
How hopeful are you?
I have to be an optimist. I have to talk about a glass that's half full rather than a glass that's half empty, because I know that there are things that we as a society can do, and humans and human society have demonstrated its inventiveness and its commitment to respond to global problems in the past, in terms of rebuilding from natural disasters, in terms of rebuilding after world wars. I see that what is needed is concerted action by all the countries around the world to respond to what will be a major catastrophe that will grow and grow and grow. And so what is needed is concerted action, and I am optimistic. But we not only need to reduce emissions, we need to recognize that even with rapid emission reductions, we will also need to adapt to the adverse impacts of climate change. They will occur even if we slow down emissions. We just need to reduce emissions now to determine what climate change we're likely to see in 100 years. And over the next 100 years, there will be many, many more adverse impacts from climate change, and we need to try to adapt to those, to improve the resilience of our societies and to reduce the vulnerability to climate change.
David Karoly, thanks very much.
Thank you, Adam.